Hello students, welcome to Akshara Online classes. This is Ghaffar sir, your physics faculty. Let's start our session. Today we are going to learn about class 9 IIT Foundation. The topic is energy and law of conservation of energy. So let's first start with energy, later we'll go with law of conservation of energy. So first of all, what is mean by energy? Let's see here. The energy means the capacity to do work. Understand? Energy means what? The capacity to do work. And also the units for the energy are joule. Joule is a units for the energy. Joule is the units for energy. This is a SI unit for energy. And here, look at here. This is a SI unit for energy. Even we have CGS unit. The CGS units for the energy are erg. Erg is a CGS unit of energy. Understand? And the next, let's see some forms of energy, because having different forms. In that, some important forms. Let's see here. The very first one is chemical energy. This is you can find in the case of batteries or cells. And also one more energy, electrical energy. Nowadays we are using this electrical energy for glowing the bulbs, working the TVs, fans, everything with this help of the electrical energy happening. And mechanical energy, this is actually due to position, due to motion, this mechanical energy we have. And thermal energy, so this is also one of the form of energy we can get because of the temperature, we'll get this kind of energy. And here one more thing is nuclear energy. In the sun and in the nuclear bomb, this kind of energy we will have. And the next one is the gravitational energy. This is also one of the form of energy. This is where some important forms of energy we have here. And now we are going to discuss about here. Now we are going to discuss here the mechanical energy. So let's see what is mechanical energy and what is the types of mechanical energy we have. So let's see, the mechanical energy means it is a sum of kinetic energy and potential energy. Understand? So simply, what is by mechanical energy? It is a sum of potential energy and kinetic energy. Now one by one we'll learn kinetic energy and potential energy detailedly. Later we're going to discuss about law of conservation of energy. The very first one is potential energy. Potential energy. What is this potential energy? Potential energy means the energy possessed by a body by virtue of its position or configuration. Understand? By virtue of its position, due to configuration, the objects having the energy. So let's see where the object having the energy with a pictures. So this is one picture. This is a bow. The bow having the potential energy because its configuration. When we stretch the bow will gain the energy. That is a form of potential energy. And also one more. So here a object we have. The object is at some certain height. Due to this height, this object possesses the energy. The kind of energy is known as potential energy. Anyhow, we have one of the form of potential energy, that is called the gravitational potential energy. The formula for gravitational potential energy, PE is equal to mgh, because due to height, the object possesses some energy, that is called gravitational potential energy. Formula for gravitational potential energy is what? mgh. Here m means mass of the body, g means acceleration due to gravity, h means height where it is having. Okay, this is very important. Further we'll use this formula. And next one is kinetic energy. So what is this kinetic energy? The energy possessed by a body but by virtue of its motion is known as kinetic energy. And the formula for kinetic energy is kinetic energy formula is half mv square. Here m means mass of the body, v is the velocity of the body. Because of the velocity, because of the motion, the energy possessed by the body is known as kinetic energy. Let's see where the objects are having the energy by pictures. So here this is a man is riding the bicycle having kinetic energy, as well as a bus is moving having kinetic energy because of its motion. And if aeroplane also, so look at here, this is a flying aeroplane also having kinetic energy. Even this aeroplane, due to its height, even it possesses potential energy also, which means that this aeroplane possesses kinetic energy as well as potential energy. Understand? Because of its position, because of its height, it possesses potential energy. Because of its motion, it possesses kinetic energy. Both energies this aeroplane will have. Now let's see this. Now very important, this kinetic energy formula, half mv square. Further we'll use this formula. And now let's see law of conservation of energy. What is this law of conservation of energy? The law of conservation of energy says that energy neither be created nor be destroyed, it changes from one form to other form. So simply it is telling that the total energy is constant. Understand? So what is telling that? The total energy is constant. So even we can say this form is another way. The change in energy, change in mechanical energy also zero, which means that when energy remains constant, the change is become zero. So that is what the law of conservation of energy is representing us. Now this law of conservation of energy we can apply for example. The example is nothing but freely falling body. For the freely falling body, how we can show the energy is constant for the freely falling body. Let's see with an example here. So this is a law of conservation of energy for freely falling body. Let me take a freely falling body. The object is now falling freely. When the object is falling freely, now look at here, this is a ground. From this ground it is falling from certain height h. This you can take h height. When it is falling from certain height h, let's prove that the total energy of this freely falling body is constant. For that, I'll choose 3 points. First point is initial position. Let me take this position is A, and middle over the journey, somewhere over here you can take position B. Somewhere over here, about to reach the ground, you can take position C. Now let us observe the position A, position B, position C, the energy, total energy of the body. So for that, let me take first of all position A. Position A. At position A, let us see the total energy. You know total energy, just now we discussed that potential energy plus kinetic energy. So now as it is falling freely, initially it has a velocity 0. When velocity is 0, the kinetic energy becomes 0. But it is at certain height h, since it possesses only what kind of energy? Gravitational potential energy. Now totally, the total energy at A become, total energy at A, potential energy is what? mgh, because this is having mass m. When this is having mass m, m is the mass, g is the acceleration due to gravity, and h is the height. Because of this height, the energy it is having. And plus 0. Why it is 0? The kinetic energy is 0 because velocity is 0. So why if velocity is 0, why kinetic energy is 0? Because kinetic energy formula is half mv square. In that mv square, v value is 0 since kinetic energy is 0. So total energy at A is mgh. So this is the energy at A. Let us see energy at B. Position C. Energy at position B. Now at position B, so this is a position B. But when this is a position B, it is covered some x distance down, and it is at when it covered x distance down, it is at a height of h minus x distance. When is at height of h minus x distance, and it is in motion, so that it possesses two kind of energies. One is potential energy as well as kinetic energy. Now total energy at B is equal to again PE plus KE. Now due to height it is possess potential energy, so I can write mg h minus x plus due to velocity it possesses kinetic energy, that is half mv square. Now mg h minus so look at here, mgh minus mgx plus half v square I can write as 2gx, because if I apply second equation of motion, total energy at B, if I apply third equation of motion, that is v square minus u square equal to 2ax, so it become initial velocity 0, so that when initial velocity is 0, it become v square is equal to 2gx. So instead of v square I have written 2gx, so that 2 gets cancelled. Remaining thing is total energy at B is equal to mg h minus mgx plus mgx. This mgx gets cancelled. The remaining equation is total energy is at B is equal to mgh. Now this is the total energy at B. Similar way, total energy at C, total energy position C. Let's see position C. At position C, total energy at C is equal again PE plus KE. PE plus KE. So here we are observing now potential energy at C. Now you know when it is about to reach the ground, we don't have any height since potential energy is 0, and it is having potential energy you can take 0 because it is not having any height, and kinetic energy I can write half mv square. Again by using the same relation, that is v square minus u square equal to 2as, v square minus u square equal to 2as. In that a value I can take g, the x value I can take total height covered by the body, that is h. Now I can write v square, now I can write here v square is equal to 2gh. Same thing if I apply here, total energy at C is equal to half m 2gh, 2 gets cancelled, total energy at C is equal to mgh. So this is the way total energy at C. Now observe that energy at A, energy at B, energy at C, everywhere we have same mgh, means total energy at all situations would be the same. So that is what the proof of law of conservation of energy. Now what are the conclusions you can get from here? You can get the conclusions. First thing is, at A initially the total energy is in the form of potential energy. That is the first conclusion. And as it is going down, the total potential energy gets converted into kinetic energy. Finally, when about to reach the ground, the total potential energy got converted into kinetic energy. This is the conclusions you can make from here. Understand? So I hope this you have understood this derivation. So this is the way we can find the law of conservation of energy. So thank you, children. This is the way we can find in another situation also. Bye bye.